Welcome back to Remote Explorations, guys. It's me, Sinjan, again. And as promised in the previous week, after a short analysis of ISI 2025's entrance examination of B.Stat and B.Math, I have come up with the solutions. It took a little bit of time since I was busy with my exams. So, some basic rules to follow while seeing the solution. For the better understanding of the audience, I have decided that I will be posting out the videos in three different parts for my UGA. That is in part 1, which I am uploading today. It will be covering question number 1 to 10 of the first paper, that is of the objective paper, that is the UGA paper. Tomorrow's video will be consisting of problems 11 to 20. The next day's video will be consisting of problems 21 to 30. Before I move on to UGB's problems, now as you can see from the heading here itself, I have excluded 6 and 8 since I think question number 6 and 8 requires a bit more of conceptual clarity, and hence, just like these, which I am classifying them as a little bit of tough problems, I will be doing it in a fourth video, which will be posted just after the three videos are done before the solving of UGB's paper. So yeah, without further ado, let's get started. My first question is basically a very easy pairs of straight lines or coordinate geometry question. It is said in the xy plane the curve 3x cube y plus 6xy plus 2xy cube equals 0 represents. So this is what I am given as my equation. I need to show what equation does this represent. So as a novice, when we are solving any equation, our main motto will be to factorize it. So while we factorize this, I will be very easily taking my xy to be common, and I am getting xy into 3x square plus 6 plus 2y square equals 0. From here, I will be getting two different cases. Since my product of two expressions is 0, then either one of them must be 0. So that means my xy equals 0 or 3x square plus 6 plus 2y square equals 0. So when my xy equals 0, then it is a very easy equation of pair of straight lines, x equals to 0 or y equals to 0. X equals to 0 is basically the y-axis and y equals to 0 is basically the x-axis. So it's basically a pair of straight lines. So this case is sorted out. Next, 3x square plus 6 plus 2y square equals 0. So now this thing, if we see at it logically, this can never be equal to 0. Why? My x square being a positive term has always to be greater than equal to 0. Y square again being a positive term has to be greater than equal to 0. We are left with only 6, and now 6 can never be equal to 0. Hence, this total thing can never be equal to 0. Therefore, this case is not possible. We are left with only one case which is xy equals 0. That means my answer should be a pair of straight lines. Easy question. Question number 2. A very logically easy question based on the limits of integration. It's a definite integration question. I was given an integral I is equals to integral 3 to 5 1 by 1 plus x cube dx, and I had to basically say between what or between which value does this integration lie. Okay, so whenever we get this type of questions, our main thing would be to check out the limit of this function. So my x is lying between 3 and 5. Cool. If I cube the total inequality, I will be getting 27 is lesser than x cube is lesser than 125. Since I need my 1 plus x cube, I add a positive 1 to the inequality. So 28 is lesser than x cube plus 1 is lesser than 126. Since we ultimately are required 1 by 1 plus x cube, that is, my 1 plus x cube should be in the denominator, what do? We invert the full inequality, due to which my sign changes as given in the rules of inequality. So 1 by 28 is greater than 1 by 1 plus x cube is greater than 1 by 126. Our integral limit is 3 to 5. So basically we put here integral 3 to 5. Okay, so this thing gives us the original integration. Then the same thing we apply the integration to all the sides, like all the parts of the inequality. Now my 1 by 28 dx basically integrates to x by 28, and in place of x I will be putting my upper limit minus lower limit, which basically gives me 5 minus 3, which is 2 by 28. Similarly for 126 it is 2 by 126. Then ultimately we get 2 by 28 is greater than I is greater than 2 by 26, which says 1 by 14 is greater than I is greater than 1 by 63, which is our required option C. Easy question, fairly easy question. It's probably, I should say, JEE mains type question. These questions are very frequently asked in JEE mains. The next one, number 3. We need to find out the coefficient of x to the power 8 in this full expansion of 1 minus 3x whole to the power 6 into 1 plus 9x square whole to the power 6 into 1 plus 3x whole to the power 6. A fairly easy question again. Simple usage of binomial theorem and properties of integers, I should say. So 1 minus 3x or 1 plus 3x, does this ring a bell? It's a minus b into a plus b. My powers are same, so I can basically take the power to be common. So 1 minus 3x into 1 plus 3x whole to the power 6. So this can basically be written as 1 minus 3x into 1 plus 3x whole to the power 6. Now this remains inside the bracket. Cool. So basically a minus b into a plus b gives me a square minus b square, which is a 1 minus 3x whole square, that is 1 minus 9x square into, not into, sorry, whole to the power 6. So this is what I am getting. This is again of this form, a plus b into a minus b. I take my 6 as the power common. So 1 minus 9x square into 1 plus 9x square is ultimately 1 minus 81x to the power 4. So this is ultimately, the question reduces to finding the coefficient of x to the power 8 in the expansion of 1 minus 81 into x to the power 4 whole to the power 6. General term of a binomial, Tn 6cr 1 to the power r into minus 81 x to the power 4 whole to the power 6 minus r. We need x to the power 8. So x to the power 4 can only become x to the power 8 when my 6 minus r equals 2. That means my r is basically 4, right? Nothing more. Put r equals 4 in the full expression. Ultimately it will come 3 to the power 9 into 5 after a very easy manipulation, which is my option B. Cool. Question number 4, I exactly don't remember the question. I'll just be seeing it once. Yeah. So we have two events A and B with the probabilities P of A and P of B lying between 0 and 1, such that our usual definition of values P of A by B is basically P of A intersection B by P of B. We know it from the basics of probability. Following the same rules, we are needed to check two statements and validate those two statements as true or false. So my first statement is P of A slash B complement plus P of B plus P of A slash B. Yeah, this is what it is. We need to check whether it is one or not. So whenever we get a question of probability or Venn diagram, our main aim would be to draw the Venn diagram, to draw the union set, to draw the Venn diagram, since the Venn diagram makes the thing very easy, just as a diagram makes a question easy. So we draw the Venn diagram. We consider two sets A and B. A has X elements, B has Z elements. Take Y as the intersection, that is common elements, and the total set to be union. So P of A slash B complement is basically P of A intersection B complement by B, P of B complement. So P of B complement is basically x plus t, where t you can take it to the union set, and p of a intersection b complement is basically out of a and b complements, that gives me x. Similarly, p of a slash b is p of a intersection b by p of b. No, now my p of b is basically the things present in the circle of b, which is y and z, so y plus z, and p of a intersection b, my intersection is related, that is y. So ultimately this reduces to x by x plus t plus y by y plus z, which can never be equal to 1. Very easily it's visible. Second, so this is my false statement. Coming to the second statement, p of a complement slash b plus p of a by b equals 1. So p of a complement slash b, it is basically out of a but in of b. Ultimately if we see it, out of a but in of b, out of a, so basically my z is the only term which is out of a but inside of b. So z by y plus z, since p of b complement is y plus z, sorry, p of b is y plus z. Similarly here we are the same term repeated again, so y by y plus z, this is 1, very easily visible. So this is my true, hence my answer is statement 1 is false but statement 2 is true. Number 5, we are given an equation f of x equals 7x to the power 11 plus 4x to the power 5 minus 3. We need to say the number of real roots it has. Good question, easy one, I should say, fairly easy one. Proper usage of maxima and minima, and you get the answer in no time. Okay, so whenever we get a question of root, this is a thing to be kept in mind, and which I also will be dealing in quite details when I will be starting the course of ISI and CMI's preparation for the year 2026 from most probably July or June end. So I will be taking each concept very slowly. It will be year-long course, so I'm keeping you all up tuned. I will giving up more information, sharing the schedule, and will be doing everything possible to help you guys. So now I'm telling it in short. Whenever you need to carry out the maximization or minimization of a function, our first step would be to take out the first derivative of the function. So my f dash x is basically 77x to the power 10 plus 20x to the power 4 equals 0. Again, as a novice, when you are factorizing this, you need to take x to the power 4 to be common. So x to the power 4 into 77x to the power 6 plus 20 equals 0. That means one root is very easily visible, which is x to the power 4 equals 0 or x equals to 0. We are getting a real root. Now this faces the same kind of dilemma that our question number 1 was facing. X to the power 6 is always a positive quantity, so this can never be equal to 0. So this full quantity 77 x to the power 6 plus 20, whatever may be the case, this thing will be always greater than 0. Even if at x equals to 0 or any case like something just greater than 0, something just less than 0, positive number, negative number, for any case this thing is always going to be greater than 0. Therefore my f of x is always going to be greater than equal to 0. Hence from here we get only one root possible. Now one more way of checking is basically we have an odd degree in f of x. My question is basically x to the power 11. So whenever we have an odd degree, we very well know that it is going to cut my x-axis at least once. So without any further delay, we can say that our answer is going to be only a single real root, which is my 0. So my answer is option A, which is 0. Number 6. So this question I am keeping it for later, since this is a very famous problem. Various variations of this question has come in INMO, and I will be taking it up later. It's a good question. I fairly think it's a good question and requires a bit more amount of time than what other questions are demanding. So this is for last video. After the 3 are done, next we come up with number 7. Okay, so we are given my A, B, C, D is basically a cyclic quadrilateral. With my first information, and since I am also given my angle ADC is theta, my cyclic quadrilateral, we know that opposite angles sum up to 180 degree. So basically if my ADC is theta, then my ABC should be 180 minus theta or pi minus theta. Furthermore, we are given that my AB equals to BC. So my AB equals to BC, AD equals to CD. These two are the information given, and another information is given. AB by AD is basically 1 by 3. So if my AB is x, my AD should be 3x, and since my CD is equal to AD, then it should be 3x, and since my BC is equal to AB, it should be x. So basically BC by CD equals AB by AD equals 1 by 3. Yeah, no problem with that. Now if you look at it properly, since after all the properties have been described, if you cannot understand, then it's what we are given is the figure of a kite. And kite, the only property, basically the only property which we need for solving this question is, one is my cosine's rule. It's not a property, you need to remember the thing. And the other thing is that my longer diagonal bisects and also perpendicularly bisects the shorter diagonal. That is a property of a kite. Okay, so my, if I take this to be O, angle AOD becomes 90 degree, and angle, and not angle, AO equals OC. Cool. So what do we do now? We apply cos rule twice, keeping AC as fixed. So once we apply my cos rule in triangle ADC, and another time we apply the cos rule in triangle ABC. By cos rule in triangle ADC, I get my AC square equals to AD square plus DC square minus twice of AD into DC cos theta, cos of included angle. So basically AD square is 3x square, 3x whole square, which is my 9x square, plus 9x square minus 18x square, 2 into AD into CD, so 2 into 3x into 3x, ultimately it's 18x square into cos theta, that is cos of the angle between them. So ultimately we get AC square, applying my cos rule in triangle ADC, we get AC square equals to 18x square minus 18x square cos theta. Similarly, we apply the cosine rule in triangle ACB, which says my AC square equals to AB square plus BC square minus 2AB into BC into the cos of the included angle between the sides. Ultimately, we get AC square equals to x square plus x square minus 2x square cos of 180 minus theta. That's my included angle, 180 minus theta. So ultimately, cos of 180 minus theta is basically minus cos theta. So AC square equals 2x square plus 2x square cos theta. Equating AC square from both the relations, we get 18x square minus 18x square cos theta equals to 2x square plus 2x square cos theta. That gives me 20x square cos theta equals 16x square. So cos theta equals to 4 by 5, which is my option D. Good use of property of geometry. For people who are thinking, why am I solving this live? I am extremely sorry. I beg for pardon, since I don't have the appropriate infrastructure available with me to solve it live in front of you guys. I solved it yesterday and I'm uploading it today since I am at my home. But I hope before starting the solving of the ISI's, what should I say, UGB paper or my CMI's paper also, I hope my infrastructure will be coming and I will be able to solve it live in front of you guys. So yeah, sorry for that. Question number 8. Again a good question, and I will be keeping it for later. At one glance it might seem to be easy one, but when you try to check it once more following the basics, you will be finding it a little tough. So I'm keeping it for last. Next comes my question number 9, where it was said, I have my two numbers a and b, necessarily a less than b, and I'm also given a relation a square plus b square equals to 2025. I need to find the pair of numbers which satisfy this. Okay, this is a very common question. It's there in tomato. Nice question. Proper use of, what should I use, the proper use of ekdam basic wala congruence. So yeah, 2025 we know is 45 square. this is one method which you can apply. I wouldn't say couldn't, I didn't do it since it would be a little long. But yeah, you can give it a try, no problem. You can comment it down that yes sir, this can be solved in this way too, no problem with that. Yeah, so we know by the properties of congruence, any square number is congruent to 0 or 1 mod 3. My 2025 is divisible by 3, so it's basically congruent to 0 mod 3. Now if in one equation my RHS is congruent to 0 mod 3, then my LHS should also be congruent to 0 mod 3. Now my summation is this, so individually they must be congruent to 0 mod 3. So since congruent to 0 mod 3 basically means it should be a multiple of 3. So I take my A to be 3A1 and B to be 3B1. Basically if I put it in this equation, so 9a1 square plus 9b1 square equals to 2025. So a1 square plus b1 square equals to 225, which is 15 square. Now if you look at it carefully, one Pythagorean triplet which with practice you would be knowing just by looking at the equation is 27, 36 and 45. Since my 2025 is the square of 45, again when we come to this equation, a1 square plus b1 square equals 225, we are again getting 225, which is a square of 15, and with again practice you will be very easily knowing that 9, 12 and 15 form a Pythagorean triplet. Now following the same rule, 225 is congruent to 0 mod 3, then my a1 square and b1 square individually must be congruent to 0 mod 3. Basically then a1 must again be a multiple of 3 and b1 must again be a multiple of 3. So if you do it like this, you finally come to a point where the total thing comes up to be this. Now 3, 4, 5 becomes my basic Pythagorean triplet. All the other triplets which we have found out while calculating 3, 4, 5 are basically the multiples of 5 if we look at it properly. So 9, 12, 15. 3, 4, 5, if you multiply each term by 3, we get 9, 12 and 15, 27, 36, 45. If you multiply each number by 9, we get 27, 36, 45. So ultimately whatever we are getting, its basis is 3, 4 and 5. So ultimately we get a single pair only, since all the other things arising from the one pair itself. So my 3, 4 and 5 is the basic pair, hence only one pair is possible and my answer is B. Try to understand the logic. All the other pairs are basically the multiples of this numbers only, so we get only a single pair. Next question, the last question of today. Yeah, so 12 boxes are placed along a circle. 1, 2, 3 or 4 balls are put in such that the total number of balls in any 4 consecutive boxes is same. The number of ways this can be done is, first of all, 12 boxes are placed along a circle, so we basically place 12 boxes. 1, 2, 3 or 4 balls are put in each of them. So basically let me put x1 balls in the first box, x2 balls in the second box, and so on until x12 box in the 12th box. We are given a condition, the summation of balls in any 4 consecutive boxes remains same. So basically x1 plus x2 plus x3 plus x4 gives me k number of balls, x2 plus x3 plus x4 plus x5 again gives me k number of balls. x3 plus x4 plus x5 plus x6 gives me again k number of balls, and so on and so on. Whenever we are getting this sort of equations, and it's a question of permutation, or maybe it's a question of any topic, our main aim would be to find out relation between x1, x2 all the way till x12. So we start subtracting each equation. So we subtract these two equations, we get x1 equals to x5, this two equation x2 equals to x6, next equation x3 equals to x7, and if we keep on subtracting all the equations, we finally get the result to be x1 equals x5 equals x9. So basically my first ball, or sorry, first box, fifth box and ninth box contains the same number of balls. Similarly, second box, sixth box and 10th box contain the same number of balls. Third box, seventh box and 11th box contain the same number of balls. Fourth box, eighth box and 12th box contain the same number of balls. Okay. Now we have said in each box either 1 or 2 or 3 or 4 balls can be put. So if I put one ball in x1, then I need to put one ball in x5 and one ball in x9. Similarly, if I put 3 balls in x2, I need to put 3 balls in x6 and 3 balls in x10. So ultimately what we can see, we only have one way, or probably one way of filling x1, x5 and x9, since my x1 and x5 and x9 are always going to be same. But 4 ways of filling x1, similarly 4 ways of filling x5, and similarly filling the 4 same ways of filling x9. So either we put one ball in x1, x5 and x9, or 2 balls in x1, x5 and x9, or 3 balls in x1, x5 and x9, or 4 balls in x1, x5 and x9. So basically I can put 4 different options up here, 1 or 2 or 3 or 4. Similarly here we can put 4, since I haven't said that once I put 4 balls I cannot put 4 balls anymore. Again here 4, again here 4. Ultimately we are getting 4 into 4 into 4 into 4. So 4 to the power 4 number of choices. That means our answer should be 4 to the power 4, which is option B. Question number 11, good matrix problem. And as far as I can remember, in my previous 5 years before 2025, this question once came in the IOQM, that is the new name for pre-RMO. So do give it a try. That's all for today, since till question number 10, and I'm left with question number 6 and question number 8. These two questions which I think is a little bit tough. If you don't think, you can obviously comment down in the section. I am trying, and I will be trying to send this document in a PDF format to you for a better understanding of the solutions, since it might seem a little bit hurried for you. The paper, as I had said, was moderately easy, easier than previous year at least. It was easier one than previous year. So yeah, that's all for today, guys. Have fun, enjoy doing mathematics, and ISI and CMI is done. Just chill out right now and wait for the results and analysis. Whatever your scores are, do comment me in my comment section. Yeah, that's all for today. I will be coming up with another video of solving question number 11 to 20 in my next one, that is probably tomorrow. So yeah guys, goodbye, see you soon, take care.